going to be talking about the game of NIM. So NIM is a two-player game where players take turns removing objects from distinct piles. On each turn, players must remove at least one object from a single pile, and they can remove any number of objects from that pile. And the player forced to take the last object loses the game. So, for example, we have our three piles here of 3 matches, 4 matches, and 5 matches, and the goal is to avoid being the player who takes the last object. And when it's your turn, you could take one match off of the 5th row, or you could take all the matches off of the 4th row. Just on every turn, you're only allowed to mess with one pile of the matches. So in order to master NIM, we need to understand binary numbers first. So binary is a number system that only uses 0 and 1s represented by powers of 2. So for example, if we have the number 1, 0, 1 in binary, what this is we're going to have it represented by 2 to the power of 2 multiplied by 1, plus the 0 is going to be 2 to the power 1 multiplied by 0, plus 2 to the power of 0 multiplied by 1, which gives us 2 to the power 2 is 4, plus 1, 4 multiplied by 1, which gives us 4, plus 2 to the power 1 multiplied by 0, which is 0, plus 2 to the power of 0 multiplied by 1, which is 1, which will give us the final answer of 5. So now if we look at our example here of a row with 3 matches, a row with 4 matches, and a row with 5 matches, our first goal is going to be putting all those numbers into binary. So if we have our binary here, and I'll write it out, we're going to go right to left from small numbers. So we have 2 to the power of 0, which is 1, 2 to the power 1 is 2, and 2 to the power 2 is 4. So in order to get 3, what we need to do is we need to look up here and see that we need 2 plus 1. So we're going to have 0 4s, 1 2, and 1 1. Now 4 is going to be 1 4, 0 2s, and 0 1s. And finally our 5 is going to be 1 4, 0 2s, and 1 1. We're going to draw a line like that, and then we'll start our next step. Alright, so next we're going to perform a XOR operation, so the XOR gate operation, on these binaries numbers. So what the XOR does is it compares each bit of the numbers and returns 1 if the bits are different and 0 if they are the same. So we can see here we have 2 1s which are the same, which will give us a 0. Here though, we only have 1, and because that's different, we're going to have a 1 here. And finally, we're going to have 2 1s here, which is even, so they're the same, which gives us a 0. Which means our result from our position is 0, 1, and 0. Now, the key to winning NIM is to make the XOR result that you calculate equal to 0. So if the result is 0 after your turn, then you're in a winning position, but if after your turn your XOR result is not 0, then that means you're in a losing position. So what we need to do for our example is we see that our answer is a 2, because that's what it is in decimal. 0 1 0 in binary is equal to 2 in decimal. So in order to get this 1 to go away, to get us the situation that we want, we're going to look at the middle row, because that's where our problem is. And we're going to see that our problem is this one up top in the 3 row. So one way that we can have this become the result of 0 is by getting rid of this 1. And we know that in order to get rid of the 1, we will have to make the new binary of 0, 0, and 1. But 0, 0, and 1 is equal to 1. And now we have to try to figure out how to get 3 to go to 1. So because this is a pretty easy example, we know that we just need to subtract 2, which means taking away 2 matches from the row of 3. which means our new binary will be 0, 0, 1, 1, 0, 0, and 1, 0, 1. Which now, if we do our XOR, is going to be 1 and 1, which is the even, so that's going to be a 0. All zeros is going to be 0, and even number ones is going to be 0, which means that now we are in a winning position.